Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of circular motion, we have seen the basics of the circular motion. So first session we have seen the angular terms, what is angular displacement, angular velocity and the angular acceleration, right? In the last session, second class, we have seen what is the tangential acceleration, what is the centripetal acceleration, right? So, and what is the relation between the tangential acceleration and the the angular acceleration, right? So all these things we have discussed in the last class, right? So now in today's session of circular motion lecture number 3, where we are going to discuss the dynamics of the circular motion. So already we have started the force part, right? What is the centripetal force? If there is a centripetal acceleration, so then obviously without force there should not be any acceleration, right? So that means there should be some force acting towards the center while the body or particle moving in the circular motion. So that force which acts towards the center and which causing the centripetal acceleration is called the centripetal force. That's what we discussed in the last session, I guess, right? Sure. So in continuation of that, so we are going to see the dynamics of the circular motion today. Okay, so we will see what is conical pendulum and then with how much speed it should be moved, and we'll also see the death well or rotor. So all these concepts we are going to discuss. Okay, so just I need your attention for the next 1 hour. Avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes. Okay, so without wasting much time, so with very high positive energy, let's get into the today's topic. Chalo. So before going for the question, so let me recap the last part of the previous session. So where if the body is moving in a circular path, so consider the body is moving in a circular path. So here is a particle which is moving. So the centripetal acceleration always acts towards the center, right? So now, so there should be some force towards the center so that the acceleration is causing towards the center. If without force there should not be any acceleration, right? So then the force which causes this acceleration is called the centripetal acceleration. So this Fc is the centripetal acceleration, right? The centripetal acceleration. So where this Fc formula we have seen it in the last class. So where Fc is equals to m into the centripetal acceleration, right? So m into, in place of centripetal acceleration we can write either v square by r, or we can write v m v omega or m r omega square. So all these formulas are possible. So the Fc is equals to mv square by r and mr omega square and mv omega. So all these are possible, right? Chalo. So and then we have also seen that the centripetal force is not a new kind of force, right? The centripetal force, it's not a new kind of force. Let's suppose if the earth is revolving around the sun, okay, so then the gravitational force between these two will act as a centripetal force. So here the centripetal force will be equals to the gravitational force between those two. Yes or no? And then we have also seen, so if a stone is attached to the string which is of length L, so then if it is reeled in a horizontal circle like this, so in this string the tension will be developed towards the center. So this tension will act as a centripetal force, right? So this tension will act as a centripetal force. Understanding? So that means the centripetal force is not a new kind of force. So depending on the situation, some other force will act as a centripetal force. Okay, so now we'll solve the question so that you'll understand even better. Okay, so let's see the question. Pause the video and try this question on your own, guys. Pause the video and try this question on your own. First go. So what's the question says? A ball of mass 0.25 kg attached to the end of a string of length 1.96 meters. So here is a string which is of 1.96 meters, and here is a ball whose mass is 0.25 kg. Whose mass is 0.25 kg. So now is moving in a horizontal circle. So this is moving in a horizontal circle like this. Fine. So now the string will break if the tension is more than 25 newtons. If tension is more than 25 newtons, so then the string will break. Fine. So then what is the maximum speed with which the ball can be moved? So with what maximum speed the ball should be moved? So that's a question. See, so in this particular case, so this is the center of this circular path, let's suppose. So and then, or else let me write. So this is the center of this circular path. So here towards the center there acts some force which is called the centripetal force, and away from this mass away from this mass, so the tension acts. So in this particular case, so the tension will be equals to the centripetal force. Sorry guys, I'm having cough and cold, so please don't mind. So the T is equals to Fc, right? So now in this particular situation, what they are saying, the string will break if the tension exceeds 25 newtons. So the string will break if the tension exceeds 25 newtons. So that means your centripetal force should be less than or equals to T. Yes or no? So then the mv square by r I am taking here, so is less than or equals to maximum tension. So from here find the V value. So what is that V value we get? So the mv square by r should be less than 25 newtons. So what is the mass? Or else let's write. So the V square should be less than or equals to 25 into r by m. So what is V square here? R here. So 25 into r is, what is r? R is given as 1.96 by, so mass is 0.25, right? So let's write it as V square is less than or equals to 25 into, so here 196 I am writing by 25. Why? Because this is 25 by 100 I am writing. 100 if I send it to that side, so it will become 196, and then 25 cancel. So V square must be less than or equals to 196. So the V must be less than or equals to 14. So that means what is the maximum speed? So the V maximum is equals to 14 meter per second. So if it moves more than this speed, so then the string will break. So the maximum speed with which the ball can be moved is going to be 14 meter per second. Clear guys? Understood the concept? So let's move further. So see the question, read the question properly and try to answer yourself. One end of a string of length is connected to a particle of mass m. So this is the string, and one end is connected to particle of mass m, and the other end is connected to a small peg on a smooth horizontal table. Okay, fine. So if the particle moves in a circular path, so if the particle is moving in a circular path, so with speed v, so it is moving in a circular path, speed v, like this. So like this it is moving. Okay, so then the net force on the particle will be, see what is the force acting on the particle? So the force will act on the particle towards the center. So shall I say that that force will be equals to the tension? That force will be equals to the tension. So that's what they are asking, right? Direct question. So what is the force that acts on the particle? The only force that is acting on the particle is the tension force, which is towards the center. So and towards the center another force is also acting, which is centripetal force. So here the centripetal force is nothing but the tension force. So that's what they are asking. So directly you can put T. Done. Simple question. Chalo, so let's take next question. So what's the question says? Two stones of masses m and 2m are drilled in a horizontal circles. So the heavier one in a radius of r by 2 and the lighter one in a radius of r. See here, so understand the question properly. This is of circle r/2 radius, and then this is of circle radius r. Fine. Chalo. So the heavier one in r/2. So here 2m mass in r/2 one. So and in r1 which is in m, right? Chalo. So now the tangential speed of lighter one is n times that of the heavier one. So where is the lighter one here? So this is the lighter one. See here, the tangential speed of the lighter stone is n times that of the heavier stone. So let the heavier stone speed be v, so that the lighter one speed be nv. So just a minute guys, I'll have some water. Sorry. So see here, so the heavier one speed, the lighter one speed is n times that of the value of the heavier stone. So let the heavier stone tangential speed is v and the lighter one will have nv. Now they experience the same centripetal forces. See here, when they experience the same centripetal force. So here if the centripetal force is Fc, here also the centripetal force is Fc they are saying. So the both the centripetal forces are equal. So this is the hint that they gave it in the question. So now what is the centripetal force formula? So mv square by r, m. So in the first case what is the v? So let it be v itself by, so the radius r/2, radius r/2. And in the second one, so what is the v, which is nv square into mass is how much? Sorry, here mass is 2m, right? In this first case mass is 2m into velocity is v. So mv square, m means 2m into v square by, so radius is r/2. So in the second case, so mass is m into the velocity is nv, so nv whole square by the radius is r. So now you do the calculation. So send this 2 to upside. So 4mv square by r is equals to here n square v square m by r, right? So here mv square cancel, r cancel, n square is equals to 4. So then n is equals to 2. So they are saying the value of n is 2. Clear? Understood guys, everyone? Done? Chal. So let's move further. So now let's come to the concept of conical pendulum. See, the conical pendulum in general words, if I can say, just this is a fixed end and you attach a string and to the end of the string. So what you do is you just attach a some mass. Okay. So then you reel it this way. So then what happens? So then a cone will form. So then that is called the conical pendulum. Yes or no? Like this, a cone will be formed, right? So I don't have anything to show here. I guess we have this, but this is broken. So see this one. So this is of mass m. So then if I reel it in a vertical circle like this, so then what happens? See, no, sorry, horizontal circle like this. So here you can see the cone formation. Here you can see the cone formation from the top. Yes or no? So the same thing we are doing here. So the cone formation, this is called the conical pendulum. So now the thing is, while it is rotating in a horizontal circle like this, So here towards the center, the force that acts, what is the force that acts towards the center? We know the centripetal force Fc, So now in this string, so the tension will be T. This string, in the string, the tension will be T, right? So if I draw the parallel line here, so if this angle is theta, so this angle is also going to be theta. So now there are two components for the tension. So one is, this is T cos theta component, and this side the T sin theta component. this side the t sin theta component, and then so downward, so its weight will act mg. So from this diagram, so I can say that Fc is equals to t sin theta. The centripetal force will be equals to t sin theta. Okay, now clear this part. And then so one more thing, so the t cos theta is balanced by its weight mg. The t cos theta is balanced by its weight mg. So now the Fc means we know that mv square by r, let it be. So t sin theta. So then here t cos theta is equals to mg, let it be the equation number 2. So now what I am doing is, let's divide equation 1 by equation 2, so that we get the t sin theta by the t cos theta is equals to mv square by r by mg. mv square by r by mg. So from here t cancel, so sin theta by cos theta, tan theta, which is equals to m cancel, so the v square by rg. So this is one formula that you should remember. So where the tan theta is equals to v square by rg. So now, so from here you can write the v square is equals to rg tan theta. So with what speed it rotates, it moves in a circular path, if they say, so the speed v is equals to root over rg tan theta. V is equals to root over rg tan theta. So this one thing you should remember. And so we can further find the time period of this circular path. The time period means to complete one circle, to complete one complete revolution. So how much time does it take? So that also we can find. So how do we find? Let's see. See, so we have got v is equals to square root of rg tan theta, right? So now I need the time period. So the time period formula is 2 pi by omega. Yes or no? Omega is equals to 2 pi by t. So time period is equals to 2 pi by omega. Shall we write? So from here, shall I write? We need omega. So we know the relation that v is equals to r omega. We know the relation v is equals to r omega. So from here, shall I find omega is equals to v by r, right? Omega is equals to what do v is root over rg tan theta by r. So now what I am doing is, let's write this r also in square. So root over rg tan theta by, so square root of r square I am writing. Square root of r square, root square cancel, again r will be left. So then I can write this as, so write it in the complete one square. So rg tan theta by r square. So here 1r cancel, which is nothing but root over g tan theta by r. Root over g tan theta by r. So now we can do one more thing. So that is, see here, so let's consider this circle has a radius r, right? So then shall I say that the sin theta is equals to, from here, opposite r by the hypotenuse L, right? So from here small r is equals to L sin theta. Small r is equals to L sin theta. Just I am doing the basic maths. Okay. So small r is equals to L sin theta. So let's write this aside. So now, so here we have got the omega is equals to square root of g tan theta. So which means I can write, so tan theta is sin theta by cos theta, right? So getting this part? Yes. So by r, in place of r, shall we write L sin theta? In place of r, shall we write L sin theta? Yes or no? So now see here, the omega is equals to, so we can write this as, so g sin theta by cos theta by L sin theta, which is nothing but g sin theta by, so L sin theta cos theta. Yes or no? L sin theta cos theta. So then this cancel. So the omega is equals to square root of g by L cos theta. This is the omega we got. So now what is our intention? We have to find the time period t, right? So what is the time period formula? The time period t is equals to 2 pi by omega. 2 pi by omega. So 2 pi by, in place of omega, shall we write, so root over g by L cos theta, root over g by L cos theta, which is nothing but 2 pi into, so if it goes up, so L cos theta by g, L cos theta by g. So this is a time period in the case of conical pendulum. So 2 pi into root over L cos theta by g. So if it is actually the normal pendulum, so which is of mass m, length L, so then the time period is equals to 2 pi into root over L by g, right? So but here the length, the effective length will become L cos theta, yes or no? This is a L, so the effective length will become the L cos theta. So in the case of normal pendulum, so t is equals to 2 pi into root over L by g. So in this case it's going to be L cos theta, the effective length, which is L cos theta. That's it. Clear? The basic things. So just the mathematical part is there, you just understand the steps once, the basic information. Okay, clear guys, this part, the conical pendulum? Chalo. So let's see the next one. So what's the question says, see here, the question number 4. A ball of mass 0.5 kg is attached to the end of a string having length L 0.5 meters. So the ball is rotated in a horizontal circular path about its vertical axis. So the maximum tension that string can bear is 324 newtons. So find the maximum possible value of the angular velocity of the ball. See, so here, so we have taken the linear velocity mv square by r. So if you take the angular velocity, so or else I can write for the same conical pendulum before solving the question. See here, so this is the previous one, so where, so the ball is attached this way and then it is moving in a circular path like this, and then this we have the radius L and this is a string of length L, right? So now see here, if this angle is theta, the vertical angle, so with what angular velocity it rotates? So the angular velocity it rotates is the angular acceleration, we can say the centripetal force mr omega square. So the same concept I am doing. So let this be the vertical line. So then here the tension will be there. So this angle will be theta. If it is theta, this is theta. So here it is t cos theta and here it is mg, right? And this side the t sin theta component will come. The t sin theta component will come, and then this side the centripetal force will come, yes or no? So we can say the t sin theta is equals to fc. Now I am writing this centripetal force in terms of angular velocity. Previously we wrote in terms of linear velocity, which is mv square by r. So the same thing, if the angular velocity is given, in place of mfc shall we write mr omega square? We already know this, right? And then the other one is a t cos theta, which is equals to mg. Again do the same thing. So the t, let's divide 1 by 2 the equations, 1 and then 2. So t sin theta by t cos theta, so which is tan theta, so which is equals to, we can write mr omega square by mg, right? So here m cancel, so the tan theta must be equals to r omega square by g, yes or no? R omega square by g. So this is a concept here. Clear? So now come to this question now, what they are saying in the question. So a ball of mass 0.5 kg is attached to the end of a string of length 0.5 meters. So this string is of 0.5 meters and mass is 0.5 kg. So the ball is rotated in a horizontal circular path about its vertical axis. The maximum tension that it can bear is 324. So the maximum tension, the T max, is equals to 324 newtons, right? So now find the maximum possible of angular velocity, they are saying, omega they are saying. So let's write everything in the omega terms. So when it rotates in the circular path like this, so when it rotates in the circular path like this, so then shall we say that the same thing. So here the tension T, so if this angle is theta, so this is also going to be theta, so this is t cos theta, and then which will be mg, and then this side the t sin theta component will come, yes or no? So that the t sin theta is equals to fc, here fc is mr omega square, and then t cos theta is mg, right? So let's divide these two equations. We got the tan theta is equals to r omega square by g, r omega square by g. So now see here, so we don't know the angle, so let's do one thing. The radius we know and the length we know, right? So what is the tan theta is equals to here opposite by adjacent, or else let's do one thing. We got, or else you can just substitute the values, I guess. Tension is given, let it be in terms of theta is not, or else you can just use this equation, guys. No need to go for the second equation also. You can just use this equation, t sin theta is equals to mr square. So here let this t be t, so in place of sin theta, so shall I write, let this angle, let this be radius r and this one l, so which is nothing but r by l sin theta, here mr omega square. So here r cancel, so we can write, so the tension T by L is equals to m omega square. So from here, so the omega square is equals to T by ml, right? So then omega is equals to square root of T by ml, right? So here they are saying what is the maximum possible value of angular velocity. So we have to find omega max. So that omega max will be equals to square root of, so if omega is maximum, the tension should be maximum, right? So take the T max value by m into L. So that's it. So square root of what is the maximum tension? So 324 by the mass is 0.5 and length is 0.5. 0.5 into 0.5. So which you can take 0.5 out, and then this value, it's going to be 18, right? So 64, 8, 14, 8, 2. So this is 4, 12, 412, sorry, 324 only, right? Yes. So then this is going to be 1 by 2, you can take, or else, my bad, just a minute. So this is 1 by 0.5 comes out into square root of, so just write 324. So 324 is nothing but 18. So this is 18 into 0.15 by 0.15, which is nothing but 2 comes up. So this is 36 radian per second. So the correct answer should be 36 radian per second. Clear? Understood, guys? Everyone? Chal. Done? Let's see the next one. So the next concept is the death well or rotor. So the same concept, understand the concept here. So let's suppose this is a vertical well or something vertical circle type thing. Okay. So the bike riders, they used to ride on the vertical wall, right? Have you seen in the circus or some stunts they do, right? So the in the vertical circle, so or in the cage, the spherical cage, so they ride their motor bicycles, so horizontally, right? So in such cases, so with what maximum speed they should move along the horizontal surface, along this vertical surface of the cage, so that they will not fall? Yes or no? So they ride on the horizontal surface, right? This is a cage, this is a whole cage, so they ride in that circle. They should not fall, right? So if they should not fall, so how much minimum speed they should maintain? Okay, so that we are going to see here. See, let's suppose, so this is a vertical well or some vertical cage, whatever. So here the bike rider is riding the bike on this wall, just on the wall. Just imagine on the walls of your room. If your room is, let's say, the circle type thing, so the bike rider has to ride his bike on the walls, just on the walls. So then he should not fall. Here is a bike rider, let's suppose. So then what are the forces acting on this person? His own weight will act downward, mg. Yes. So then, so there is a chance that he may fall downward, right, because of his weight. So then obviously the friction should act upward. So the friction should act upward. It should oppose the relative motion, right? And then, so we have towards the center, so there will be the normal force here is a point of contact which will be equals to normal, and then so here we also have the centripetal force. Let's suppose he is moving with some velocity v, so the centripetal force is equals to Fc. The centripetal force is equals to Fc. Yes or no? So understanding the basic concepts. So which means here the person, the Fc is equals to n, the normal Fc is equals to n. And then, so if the bike rider should not fall, so then the F limiting for safe riding, shall we say, so the F limiting must be greater than or equals to mg. The F limiting must be greater than or equals to mg, right? So here the Fc is equals to n. So what is n? So in place of n, shall I write the normal is equals to, let's consider the linear velocity mv square by r. Okay, so in place of F limiting we can write mu n should be greater than or equals to mg. So then in place of mu into in place of n, shall we write mv square by r, right? So then the v must be greater than or equals to mg. So then, yes or no? So then here mu into, so m cancel, v square by r should be greater than or equals to g. So then here mu v square, so should be greater than or equals to rg. So from here, so the v square should be greater than or equals to rg by mu. So that means his velocity should be greater than or equals to rg by mu. So that means the minimum velocity with which he should ride the bike on the surface is rg by mu. So if he is not riding his bike with this speed, so he will fall into the circle. Yes or no? He will fall into the cage, whatever it is. Understood, guys? Clear this part? Just we did not do anything. So basic concept I applied, and we got the with what minimum speed on the horizontal circle he should move, so that he will not fall into the circle, right? Done. Chalo. So here another case is also possible, rotor. What is the rotor? So here consider this is a rotor which is moving about its axis with some angular velocity omega. So this rotor is moving with some angular velocity omega. So now we placed a block, or a person is standing here. A person is just attached to this, or a mass, some mass is attached to this rotor. So now with what is like he should not fall into the rotor. The rotor will move, he should not fall. So what should be the angular velocity? So the same concept here also. So the normal reaction will act this side, and then so towards the center there will be the centripetal force, and then as the rotor is moving, so this side the F limiting will act, and then downside mg, right? So in this particular case, so the Fc is equals to the normal, right? So in this case the Fc is equals to, so normal is equals to, so as the rotor is moving, previously the biker, this total setup is constant, the biker is moving in that circle, right? So here that total setup is moving, so the person is constant, the person is stationary, okay now. So with what velocity, with what angular velocity that rotor should be moved, maximum velocity, so that the person who is standing or who is attached to that rotor will not fall into it. Okay, that's the concept. So that normal will be equals to, we know that the centripetal force in terms of angular velocity mr omega square, and then here, so to not fall, the F limiting should be greater than or equals to mg. So then only he will not fall. So what is F limiting? So the mu n should be greater than or equals to mg, and then so mu into, in place of n, so we can write mr omega square, mr omega square greater than or equals to mg. So from here, so m cancel, so we can write the omega square must be greater than or equals to g by mu r, g by mu r. So that means the omega should be greater than or equals to, so root over g by mu r, root over g by mu r. So that means the minimum angular velocity with which the rotor should be moved. So not minimum, the maximum with which it should be moved is root over g by mu r. So this is the maximum angular velocity, so that the person will not fall. So if the angular velocity exceeds this one, the person will fall into it, or the block which is attached to this rotor will fall into it. Clear the concept, this one and this part? Everyone done? Chalo. So let's move further. So let's see simple question, guys. So the question number 5, what's the question says? If the radius of the rotor is 2 meters, if the coefficient of static friction between the wall and the person is 0.2, so find the minimum speed at which the floor may be removed. So find the minimum speed with the floor may be removed. So here is a person. So the radius of the rotor, here this is mentioned as rotor. So the rotor radius is 2 meters and the coefficient of friction is given 0.2. So then find the minimum speed, so with which the floor may be removed. So if the floor is removed, the person will be attached to the rotor. So the rotor is moving with some angular velocity omega. That's what they are saying. So here v they are asking or omega they are asking, just understand. So v they are asking, see here, meter per second they given. So see, we know that the v minimum or the minimum speed at which, so root over rg by mu, yes or no? So just now we have seen, so the v minimum is equals to root over rg by mu. So just substitute the value. So root over r, what is r? Radius is 2, g is 10, mu is 0.2. So direct formula based question. So 2 into 10, so let's write this as 2 by 10. So 2, write it here, 10 upside. So then 2 cancel. So this is going to be 10 meter per second. So option 2 is the correct one. Clear, guys? Sure. So let's move further. So let's take one more question which was asked in NEET 2019. So what they are saying, a block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. The coefficient of friction is 0.1. Okay. So the minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis. See here, this is the cylinder, so which is rotating about its vertical axis. Okay. So then a block is attached to this cylindrical rotor. This is moving, the cylinder is moving continuously like this, rotating. Okay, so here a block of mass m is attached which is of 10 kg mass against the inner wall of the hollow cylindrical drum of radius 1 meter. Now, so what they are saying, the minimum angular velocity. So just now we have derived the formula. So the minimum angular velocity which is equals to root over g by mu, omega is equals to root over g by mu r. That's it. Yes or no? So then, so root over g, what is g? 10. Mu, what is mu? That is given mu 0.1 into r, radius. So what is the radius? Radius 1. So then this is root over 100. Again this should be 10 radian per second. So 10 radian per second. So direct formula based question, option 4 is the correct one. Omega they are asking directly. Yes or no? We know the formula for omega directly. Done. Chal. So next, see here. So the another kind of force, that is the centrifugal force. So actually this centrifugal force is a imaginary force. This centrifugal force is a imaginary force. So try to understand the concepts clearly here. So the centrifugal force is like a imaginary force, means the pseudo force. So when observer is rotating in the accelerated frame, let's suppose this is a circular path. So the observer is inside this car now. Okay. So that means the observer is in the accelerated frame because there is the centripetal acceleration acting on the person. The centripetal acceleration which is towards the center. Right. So then there, whenever the observer is in the accelerated frame, in the Newton's laws of motion we studied, right? What is that? So then the opposite force that acts is the centrifugal force. Here the centrifugal force should act on the person. So that's why here the centrifugal force will act outward. In this particular case, the centrifugal force acts outward. Yes or no? Simple logic. What you understand is, if the person is in the accelerated frame and there is a force, centripetal force is acting towards the center, that means this person should fall into the circle, right? This person should be pulled towards the center. Yes or no? So then that is not happening, right? When we are moving in a circular path, so we will not pull towards the center, right? Why? Because there is an equal and opposite force which is acting outwards. So what is that imaginary force which is acting outward? The centrifugal force, basic thing, right? So I'll tell you through example. See, so in the case of conical pendulum we have seen, so here the tension is T, and let's suppose if you take this vertical line, so this is going to be angle theta, right? So now we know that there is a centripetal force which acts towards the center, right? Or else the tension which acts towards the center here, this is a tension T. So and then this side the T cos theta will come, and then this side the T sin theta component will come, and this side the mg. So this T sin theta is a centripetal force. This is a centripetal force. So now due to this centripetal force, so this block of mass m should come into the circle. It will be pulled towards this side, right? But that is not happening. It is still rotating or moving in the circular path. So what is the reason? So the reason is simple. So there is an equal force is acting outward, so which is the centrifugal force. There is an equal force which is acting outward, so that is the centrifugal force. So what is that centrifugal force? That is mv square by r. So the centrifugal force will be equals to mv square by r. So that's why in this particular case the T sin theta is equals to mv square by r, and then the T cos theta is equals to mg. That's it. Again we get the same thing. So previously the centripetal force is equals to the T sin theta we took. So whatever the centripetal force that is acting towards the center, so the equal and opposite imaginary force that is called centrifugal force will act on the body outward direction. The centrifugal force, centripetal is towards the center, centrifugal is outwards, okay, away from the center. So away from the center like this. So which is equals to, again we get the same result, right? So where we get V is equals to square root of Rg tan theta, or if you find the time period, so we get 2 pi into root over L cos theta by G, right? So these are the results we have seen for the conical pendulum. Done. So even you can apply it for the death well or rotor also. So here is a person, right? So then the towards the center we know the normal reaction is acting, so that normal should be balanced by the centrifugal force, which is nothing but either mr omega square or mv square by r. So here the F limiting should act upward, and then downward the mg should act. So here the n will be equals to mr omega square, or n is also equals to, in terms of linear velocity if you take, the mv square by r, which is a centrifugal force, right? Previously the normal and centripetal force, they both are acting in the same direction. That's why normal is equals to centripetal force we took. So here the centripetal force is equals to centrifugal force, which acts outward. Equal and opposite force, that's a centrifugal and centripetal, which acts outward is a centrifugal, which acts towards is a centripetal, right? So that's what we took. So in n is balanced by here mr omega square, the equilibrium condition. So you can take this, and then the F limiting should be greater than equals to mg. So again you can do the same calculation for the death well or rotor. So just I'm saying, whether you consider the centripetal force or centrifugal force, the formulas are going to be same. Yes or no? So here the centrifugal is this side, but in the previous case, so while we are solving the question derivation, so we took normal is acting towards the center and centripetal force is also acting towards center. So the somehow some other force will act as a centripetal force. That's what we discussed, right? So here the centripetal force is nothing but normal. So in the previous case, so the centripetal force is nothing but, where is it? So in the previous case, the centripetal force is nothing but the T sin theta, right? So now I can also say that the T sin theta will also balanced by the equal and opposite force of the centripetal force, which is the centrifugal force. You can take the centrifugal force outward, this side. You wish, you can consider anyway. Fine? Understood the concept? Chalo, so let's move further. Conical pendulum and death well or rotor. So now, so the bending of a cyclist, so as I discussed earlier, so the same concept. So if the person is moving along the circular path, so with what speed he should maintain, maximum speed. So and at what angle he should bend. So the angle at which he should bend is tan theta is equals to V square by RG. So this is the angle at which he can bend. So without skidding. So and then the maximum velocity with which he can move at the corners or at the bending, right? So that is RG tan theta is a maximum velocity with which he can move. So the same concept you can apply. Again, N is equals to mg. So the same you'll get in the previous derivation we did, right? Same derivation. So that directly I am writing. So the maximum bending angle tan theta is equals to v square by rg, and with what maximum speed he can move at the turnings. So it is rg root over rg tan theta. That's it. Clear? So just remember these formulas. Next. So let's see this question. So try to understand this question, guys. A hemispherical bowl of radius r is rotating about its axis of symmetry, which is kept vertical. See here, here is a hemispherical bowl. So try to understand the concept. So here is a hemispherical bowl. So this hemispherical bowl has a radius r, and then it is rotating about it. Hemispherical bowl of radius r is rotating about its vertical symmetry, which is kept vertical. See here. So here it is rotating with some omega. So a small ball is kept in the bowl, rotates with the bowl without slipping on its surface. So here there is a small ball which is placed here. So what it is doing, it is also rotating in the hemispherical bowl. Just consider a bowl. So you are rotating the bowl, and inside the bowl there is a ball. So that ball is also rotating in a smaller circle. Okay, so let that smaller circle radius be, I am taking the smaller. Okay, without slipping, say there. So if the surface of the bowl is smooth, so here there is no friction acting, and the angle made by the radius through the ball with the vertical is angle theta. So the angle made by the radius of the bowl, this is the radius of the bowl. So with the vertical, this angle is given as theta, right? So then find the angular speed at which the bowl is rotating. So we have to find omega of the bowl. So now try to understand the given information. What it is given, guys? What it is given? So the bowl is rotating. First understood the concept. Here is a bowl. So you are rotating this bowl like this. Okay, and inside the bowl there is a ball. So that ball is also rotating in a smaller circle. Not at the bottom, at the along the edges of that bowl. Yes or no? It happens, right? So when you rotate the bowl, so the ball also rotates along the walls of that bowl in a smaller circle of radius r. So now they said the radius of the hemispherical bowl is making with its vertical an angle theta. So then what is the angular speed of the bowl? Omega. So now understand the concepts, guys. So what they said here, so this ball is without slipping. It is without slipping. So then what are the forces acting on it? Tell me. So just draw the diagram on your own. What are the forces? Just let me have some water. What are the forces that are going to act on the bowl? What are the forces that are acting on the bowl? Fast ga. Quick. See here. First thing is, here is the contact force, right? So then shall I say the normal reaction acts towards the center. This is the center of the hemispherical bowl. So the normal always pass through the center, right? So that's why this is the normal reaction. And this angle is theta. So I am drawing a line here. So vertical line. So parallel to this one. So if this angle is theta, this angle is going to be theta. So that this is going to be n cos theta. And then here is the ball whose weight is mg. Whose weight is mg. So this is one part. And then, so towards its center, so there is n sin theta which is acting towards its center. So the n sin theta is acting, and the bowl is this is rotating. So it is m in a circle of radius small r. So that the centrifugal force that acts is a mr omega square. The centrifugal force that acts is a mr omega square. So I can say that the n cos theta is equals to mg, and then the n sin theta is equals to mr omega square. The n sin theta is equals to mr omega square. So that's it. Now you got the idea. You got the idea, right? So you just divide those two equations now. You just divide those two equations. So sin theta by cos theta. So let it be equation number 2. Let it be equation number 1. So let's divide 2 by 1. So here n cancel, sin theta by cos theta, tan theta. So here mr omega square by mg. So here m cancel. So the tan theta is equals to r omega square by g. Right. So from here, let's see what is left. So we need, let's do one thing here. So let's see this one. This is r, and anything is given, the length L or something like that. Okay, fine. So this is normal. Fine. So the tan theta is equals to r omega square. Tan theta is equals to r omega square by g. So then the omega square is equals to g tan theta by r. G tan theta by r. So from here the omega is equals to square root of g tan theta by r. So if you want, you can write this small r in terms of capital R. How can you write that? So just use the basic mathematics. So just use the basic mathematics, guys. So this is the radius r, and see, observe this triangle. See, this angle is theta. So this is small r. This is capital R, right? So from here, shall I say that the sin theta is equals to opposite by hypotenuse, small r by capital R. From here, the small r is equals to, you can write in terms of the capital R, which is r sin theta. So or else you can substitute here itself. So instead of going directly for there, so the omega square is equals to, so g, let it be tan theta by, so in place of r, I am writing capital R sin theta, because we need the angular speed of the bowl. So in terms of bowl radius only we will find it. Okay. So then the omega square is equals to g into, in place of tan theta I am writing sin theta by cos theta by r sin theta. So here sin theta cancel. So the omega square is equals to g by r cos theta, right? So from here the omega is equals to square root of g by r cos theta. So the omega is equals to simply g by r cos theta. So that's what they are asking. So the omega, yes or no? Clear, guys? Done. So this is how you should solve this question. Then understand the concept first. Okay, chalo. So let's move further. So then the turning of the car. So there are 3 cases of turning of the car. So we are going to discuss. So first, on the level road, if the road is flat, okay, so on the level road, only the force that acts is the friction force. And then, so on the banking road means, like at the turnings, if you are taking the right turn, let's suppose if you are taking the right turn, so here left side, so the road will be somewhat high. So that's called banking. or if you are taking the left turn like this, so the road will be somewhat high at that turning. So that's called banking. So on the banking, the force that acts is a normal reaction. Okay. So and then, so next we'll see the next one. So the banking with friction. The third case, the banking plus friction. So in today's session, so I'll just introduce the turning of a car on the level road. So then these two we'll see it in the next session. So first let's go for level road. So the turning of a car on the level road. Level road means the road is flat, not smooth, it's flat. That means there are no ups and downs. Okay. So ups and downs in the sense the normal ups and downs will be there, but banking is not there. What does it mean by banking? At one place it's high and at one place it's low. At turnings, what they do is basically at the turnings, so they like level up the they somewhat high, the road will be somewhat high, okay, than at the other surface. That's called banking. So that happens at the turnings. So now on the level road, let's take at the turning. So on the level road, the car is taking the turning. So then what are the forces that are acting on the car? You tell me. Now you know the concepts, right? So you just tell me. What are the forces that are acting on the car? Simple thing. So what is the force that acts inside the, if the car is moving with velocity v, so the on the car, the centrifugal force outward, the centrifugal force which acts outward must be equals to mv square by r if the car is moving with v velocity. And then so towards the center there should be friction. This should be balanced by the friction. Yes or no? So then here that friction, the F limiting must be greater than or equals to mv square by r for without skidding. For without skidding. Yes or no? If the speed is more, so then what happens? Car will come out of the road and the accident will happen, right? So without skidding, right? So F limiting should be greater than or equals to mv square by r. So what is F limiting formula? So mu n must be greater than or equals to mv square by r. So what is n here? So if you take the car, so this is a car which is on the car is of mass m, let's suppose. So the normal acts upside and then mg will act downside. So the car's weight, let it be m, mass is m. So in place of normal, you can write mg must be greater than mv square by r. So that here the m cancel. So the mu g must be greater than or equals to v square by r, right? So from here, so the v square must be less than or equals to mu g r. Yes or no? So just I am writing it reverse. So then v must be less than or equals to square root of mu g r. So that means the maximum velocity with which the car should be driven at the turning on the level road is mu g r. So this is a maximum velocity which is square root of mu g r. Okay na? So without skidding for safe turning, so what is that velocity? V max for safe turning. What is the maximum velocity? So this is for safe turning. Hope you guys are understanding. I'm a bit uneasy, so that's why some energy levels are low, but I am teaching the concept. Whatever that is there, I'm teaching it completely. Okay, chalo. Chalo, next. So let's take one question here. What's the question says, guys? Try this question on your own. So an unbanked curve, unbanked means the level road, has radius 30 meters and the maximum speed with which car can turn if the coefficient of friction mu is equals to 0.75. Let's take it as 3/4. So the maximum speed, so the V max on the level road, we know the formula, square root of mu g r. So the mu value, the coefficient of friction is given. So the coefficient of friction, if the coefficient of friction is 3/4, g value 10 and then r value 30, right? So this is going to be square root of this is 30, 900 by 4, right? So which is nothing but 30 by 2, so which is 15 meter per second. So the maximum speed with which can for the safe turning is 15 meter per second. Clear? Chal. So let's see the next question. A gramophone record is revolving with an angular velocity omega. So a coin is placed at a distance r from the center of the record. See here, let's suppose this is a gramophone, so which is revolving it with a angular velocity omega. So now a coin is placed at here is the coin which is placed at the distance r. Okay, so the static coefficient of friction is mu. Here the coefficient of friction is mu. So the coin will revolve with the record if. So the coin will revolve. So with the record. So with the gramophone record, it should revolve. So if that means it should not fall. It should not fall. So that's what they are saying. So the simple concept again. So the basic understanding is, so here when it is moving, what are all the forces that are acting? Tell me. When it is moving in a circular path along with this same hemispherical bowl type of question, you can solve it easily, I guess. So can you guys take it as a homework or should I solve? Easy question. So let's take at least one question as a homework, right? The simple question here, it is rotating in a circular path. So if it is rotating in a circular path, it should stay with it. It should stay with it. Okay. So what are the forces that are acting that they are saying? See, whenever it is there in the contact, you know, see, don't get confused, guys. Here is a normal reaction is acting, right? And outward force, you know that the mr omega square will act. So if it is rotating, the outward mr omega square, and let its weight be mg. That's it. You can easily solve it now. So this side, the friction should act, the n is equals to mg. So and then the friction is equals to mr omega square. Yes or no? Clear? This side, the friction should act, right? Yes. So if it should move with along with this, so the friction must be greater than or equals to mr omega square. Basic calculations you can do now. So you know F is a mu n. I am only teaching. Why to write here? Homework. I will give another question. Homework. So mr omega square. So here mu in place of n, we can write mg must be greater than or equals to mr omega square. So from here m cancel. So the mu g greater than or equals to r omega square, right? So from here, so the mu g by r should be greater than or equals to omega square by r. So which means the omega should be less than or equals to square root of mu g by r. So the omega should be less than or equals to mu g by. So they are asking what is r, right? The radius should be. What is that r value they should be? They are asking. So then mu g by omega square should be greater than or equals to r. So that means r should be less than or equals to mu g by omega square. R should be less than or equals to mu g by omega square. Option 3 is the correct one. So I'll give one more question as homework. See, take this question as a homework. Let's suppose here is a fixed end. Okay, and here is some mass which is 3 kg, and here it is some mass which is 2 kg. Okay, so then here let's suppose the distance from here to here it is 1 meter, and the distance from here to here it is again 1 meter, I am saying. So now let's say here the tension is, let it be T1. So here tension will be T1. So here let it be tension T2. So now find T1 by T2. So if it is rotating in an angular, it is rilled in a horizontal circle now. So it is rilled in a circle now. These two will rotate with the same angular speed. So now find T1 by T2 ratio. So what is this one? You have to find that. Find T1 by T2. So comment down this answer. Right? So the simple question. You guys can solve it easily. Okay. Chalo guys. So that's it from my end for today's session. So and we can take some more 2 lectures for the circular motion. So I'll take tomorrow and day after as well for the circular motion, because still we have to cover. So the friction, the level road completed, banking, and then banking plus friction we have to cover, and vertical circular motion also we have to cover. So still 2 more classes need to be taken for the circular motion. Okay. So chalo guys, we'll meet in the next session, that is tomorrow, with the banking questions and banking plus friction concept. So till then, keep studying. All the very best. Bye. Take care.